Hi, today we're going to be talking about quantifying your reliance on open source software with an open source project I've created called Dependency Management Data. My name is Jamie. I'm a senior software engineer at Elastic. I'm a very big blogger, so I blog about all sorts of things. That's my primary URL. I've also got an elsewhere page which lists all the other places I'm available on the web, because there's now just so many places that it's better to collect them in one place. So I'm currently working on engineering productivity at Elastic, and as part of that, that's been something that over the last few years I've been tending towards as something I actually very much enjoy, working on engineering facing problems that we can solve in a way that helps make everyone a little bit more effective. So if we have a look at the timeline of events, because this is something that I've been working towards over like 5 or 6 years, but it's only in the last few years that it's actually kind of come to fruition. So first of all, like today, we are having this talk. My first public talk about the project was just over a year ago, and the project itself was created about 18 months ago. But that was when this open source project was created, but the first iteration was made about 2 years ago now, and we'll talk a little bit more about that in a second. But then if you fast forward a few years before that, that was actually the first time I was really thinking about this problem, like how do we actually understand what open source and internal dependencies we're using, and how can we understand better what that actually means for our business and our organization. And then you go a couple of years before that, and I was writing very awful shell scripts to kind of just like parse out what sort of dependencies we had that did not work very well, and thankfully I found better ways to do it. So why is it actually important to understand how you're using open source? So I wrote a really good post about this that I just paraphrase. So in recent years, it's become like unavoidable to build on top of open source projects. That's absolutely a great thing, and it means that you can, as an organization, reduce the specialization that each team needs to have, because you can outsource some of that work to another set of open source maintainers who can understand the domain a little bit better than you, and you can then focus on some more high level stuff. And also, like, you can pick up on people fixing defects or adding features, and you don't have to do that work. So in a very selfish way, it saves you money, but in a nice way as well, it allows you to use some stuff that's built for the good of everyone. But the trouble with using things like open source is it's not always sunshine and rainbows. So I'm sure most people have seen the XKCD titled Nebraska. And so one of the problems with open source is, at the end of the day, it's usually someone who is unpaid, overly stressed, overly tired, who's been thanklessly maintaining a thing for so many years. And the only time they ever hear from their users is, hey, something's broken, or the whole internet relies on your project, why is it broken? And so if you don't really understand like the impact of all of these dependencies on the supply chain that it takes for you to actually ship your software, you're going to have a bad time. I could probably spend like several hours talking about all the different ones we've had this year with libraries that have, for instance, pulled the versions off npm or have pushed malicious malware to their code base, but I'm not, because we don't have time. And the other nice thing about knowing like how much you use open source is because maintainers like to hear nice things. They like to at least have one touch point, which isn't, hey, this thing's broken, can you fix it? Why haven't you fixed it? Why haven't you fixed it? It's nice to just know and to be able to say thank you. So even if the only thing you take away from this is just go and say thank you to one of the projects that you use. That will absolutely make someone's day. And the question is, like, do you actually appreciate the depth of your dependency on the software supply chain? The short answer is no, because it is ridiculously massive. And even with like tooling and stuff, it's still much more than you even think. And so understanding how you're using especially open source is useful for a few places. So I mentioned I'm Elastic, elephant in the room. There are lots of companies who are doing rug pulls and taking things that were open source and closed sourcing them. So being able to understand like how much you rely on different pieces of software can give you an indication of if someone does a rug pull, how bad are we going to be hit by that? There's also cases of like where are we using libraries that we don't actually want. So this could be things like where we're using things that are licensed in a way that we as an organization aren't happy with. But it could also be like we no longer recommend this library gets used. Or, for instance, we've started migrating away from Spring Boot and we want to use this other thing. So give me a list of everyone using Spring Boot. As someone in engineering productivity, it's really useful to understand like who's using which libraries and frameworks, how can we better support them. If we've got a load of teams on like a really old version of a thing for a reason, it's better to know that and to be able to go and work it out with them. And there is a massive scale of unmaintained, deprecated, or vulnerable software in the big list of things. And some of the tools you have will give you some of the insight. Not everything will know everything, but it's really important to know that. And then, as well as this being useful for open source, you can also ask almost all of these questions for your internal libraries as well. So where have you got tools that teams shouldn't be using anymore because the team that used to maintain it got laid off, things like that. You can also get some really interesting insights into things like how maintained is the dependency. Like, are the maintainers of the project taking a break from it because it's just too much? Are they keeping up to date with things like best practices around supply chain security? Or how many of them are like begging for their users to pay them like a pittance just to help make it more maintainable? Because that number is very high. Like, people need some paid effort for the amount of free work they do. So one of the ways we can do this is we could throw a load of money at the problem and buy a big vendor's solution. But instead, we're going to look at using it with open source. So the Dependency Management Data Project is very poorly named. I'm not good at naming. It kind of says what it does. But the idea is it's all about giving you access to the data for the dependencies you use. So the primary thing is you get an SQLite database off the back of it. So you have a list and you can start querying that data and understand how much you're actually using. There's a command line tool that you use to actually prepare the database. There's a web app that you can deploy and have like engineers be able to access that without having to go into SQLite on the command line. And then there's also a GraphQL API which you can integrate into other systems like Backstage. And you can use whatever tooling you want on top of the database once you've built it. So the database itself is really convenient to distribute and share. So the first version I built of this, I was literally sending the database around on Slack because it was that easy to do. Whereas if I was, say, using something like Postgres, I'd have to be like, okay, you need to use this version, here's the big database seed. It's not as easy. And it's really convenient for building local first or applications on top of it because it's just one file, it's just there. One of the key things is there's no lock-in to my tools. I made that quite a key decision. So once that database is built, you can do whatever you want with it. The idea is the database is really the main thing you get out of it. And the tools that I built on top of that are just like by the by. The main thing is you have that data in the database. So the CLI tool builds the database and it ingests different sources of dependency data that we'll talk about. And so one of the interesting things here is you can work out some really, really interesting things like how many different dependencies are different teams using, who's using deprecated stuff. But to get some really interesting things about the open source tooling you're using, there's some additional sources of data that you can enrich it with. Then as an organization, you can put your own thoughts onto it. So for instance, where are teams using internally deprecated libraries? Or where are we using things like log4shell? Visualize those. And there are some pre-built queries that you can run as well. The web app itself is centrally deployable and accessible. So as I mentioned, the idea is You deploy it where anyone can access it, internal to your organization. That is really useful because you can then send around links to people and be like, hey, this is the list of deprecated dependencies for my team, and do stuff like that. The command line tool has reports. These are also built into the browser or built into the web app, so you don't have to do command line stuff. You can just use the web app. And then there are a couple of SQLite UIs that you can use with it, which again give you that web-based but SQL-y interface. There's also an inbuilt SQLite browser, just for even more plurality. The GraphQL API can also be deployed on the web app. Yeah. And then, so there is also the separate GraphQL API, which is really useful, for instance, to integrate it into something like Backstage, a developer portal. If you want to actually run this as part of your pipelines, so say nothing can be released unless it has no deprecated software, stuff like that. So how did we actually get here? So in another blog post that I would like to paraphrase fully, this was something that while I was at Capital One, we were looking at what dependencies did we have, and this was one of my friend's side projects. But just as we were coming to the completion of the side project to work out what Java dependencies different projects had, we rolled out mend renovate, and we realized that that actually had all that available. So instead of trying to work out how to update our dependencies, we were like, okay, what could we use this data for? And so at the time in 2019, I considered, what about if we look at our dependency tree and we say, okay, we are using JUnit the most, so we should send them 10 grand a year. And then we're using this next thing the most, let's send this much money. There are now a number of other companies that are doing this as a service, and it's a great way of doing it. But yeah. And then fast forward to a couple of years later, it was coming up to Hacktoberfest, which has just started. And I wanted to get more of my colleagues at Deliveroo invested in Hacktoberfest. And one of the questions I was always getting was, well, what can I contribute to? And so I was like, well, let's get the data. Let's have a look at what projects we're using. And at this point, we're using the dependable APIs, which were fine. They were like a good starting point, but they missed a lot of data and they didn't make it very easy to work out what the current version in use was. But it was a good start for what projects we're using. And we realized that this wasn't like a one-trick pony. Having this data started us being able to answer some questions, like what versions of the Datadog SDK are we using, because we need to get to a minimum across the organization for some cost-related reasons. At Deliveroo, we started rolling out Mend Renovate as well, and at this point, we realized that there was such better data. We had many more things supported than Dependable ever will, and that data was just available to us. I then started looking at a great API called endoflife.date, and as part of that, this gave me the opportunity to decide, you know what, this should be its own project. This shouldn't be this thing that's siloed at Deliveroo. I want to be able to work on this for probably years to come, and it has been years to come. So I'm slightly running behind, so we will speed up. So one of the things here is we have like a few stages. So the first stage is you need to get some data. So for instance, in this case, we're using a tool that builds on top of Renovate to use Renovate's understanding of these are all the dependencies I have within a project. And it exposes that as a JSON blob that you can then import into the database. And as the bottom says, like you can then immediately start querying that data. So you have insight into, here are all the things we've got. In other cases, like a lot of people are working towards software bill of materials, you can also import these. For instance, even like, here is an SBOM that a vendor has given us. So let's tag that appropriately. And if we see anything that should be concerning in there, we can also report that back to the vendor. So when you import that, it creates that internal model within SQLite. And then you can start writing as much SQL as you want. So you can do things like which repos are using vulnerable log4j versions. How many repos are using a version of Datadog that's older than some date and time? or what's our most used direct or transitive dependency. But like writing that is fine, but it will be more useful to be able to say things like, so right now we can say things like what Terraform modules are people using, or which teams are using this specific framework. But something that may be more useful is, are we using any libraries that our internal language guilds or engineering productivity teams no longer recommend? Or how much time should my team be planning for the next quarter to upgrade their AWS infrastructure or their versions of things like Node.js? And to do this, we need more data to be able to solve that. So there's a few different APIs that are all open and available that we take advantage of, as well as AWS infrastructure information. But the thing is, that's all public data, but as I mentioned, you probably have internal libraries and tooling that isn't going to be publicly known about. So there's these things called custom advisories, where you can either write a fairly okay looking piece of SQL to say things like, this library is no longer maintained, or we can use policies. So using the excellent open policy agent, you can write a slightly more complex query to say things like, give me a version of the Gin web framework for the Go package manager that is version 1.9 and above. And that will then work. So we've kind of talked about a few of the use cases, but on the doc site, there are, I think, 5 or 6 much more in-depth examples that also go into some of the things we're about to talk about. So, for instance, what package advisories do I have? So these are real-life pieces of data as of this morning. So, for instance, with an Elastic in the Beats library, we are depending on a dependency that has been explicitly unmaintained. And so we need to move to the recommended one. There are cases where, for instance, the GDS Pay service are using a version of Node.js, which is deprecated but not yet unmaintained, but at some point will lose its maintenance window, at which point we won't get any security updates. And similar for content. One of the more interesting things that we did at Deliveroo was working out in the middle of an incident who else is going to be affected by this. So in this case, what we had was our internal deployment tool, Hopper, defined a version of a Kafka consumer. And as part of that, one of the things we found was there was a race condition that was affected by some of the dependency tree. And so we needed to be able to work out very quickly across hundreds of repos with YAML syntax what versions of the Kafka consumer were teams using. Now, if we were trying to use GitHub search, this would have been incredibly painful. But because we had already ingested this data into dependency management data, we were able to now see this sort of data. So we're able to see that across a few services, there are different versions. From here, we also had information around the business criticality of each of those services and repositories. And so we were then able to write a query like this. So effectively what we're doing is, give me a list of repositories, who owns them, and what business criticality tier it's at, for anyone that is using any of the affected versions of the library. And that then gave us this perfectly usable and actionable list. And things like this that are very, very useful. We don't have time to dig into Log4Shell, because again, that's quite a big one. But one of the things is, there's about 4 or 5 different ways to use this data. That also includes writing very long SQL, or using Open Policy Agent to write a much nicer version. So with the 20 seconds I've got left, this is basically all you need to do to get started. It's grab some data, create the database, import it, you're done. And you can then start doing some really interesting stuff. And one thing I didn't say, I'm naturally going to be a little bit biased. I've enjoyed this project so much, I've got a custom t-shirt printed. Like, I'm a little bit vested. But this has honestly changed the way that I view stuff at my organizations. And it's been one of those things that I'm like, I wish I had this years ago, because I would have been able to do some really impressive stuff with that. I will also leave this slide up. There are a number of links here, and my slides will also be shared. The bottom link is a link to these slides, so you can also go through. I've previously done this talk for I think about 30 to 40 minutes, so I've got a full talk write-up which goes into a little bit more detail, and yeah.